Good evening, students. Today we will see a numerical on histogram equalization. So, the statement given is perform histogram equalization on the given 3-bit image. Draw the histogram before and after equalization. And finally, comment on the quality of the image. So after drawing the histogram, we have to comment on the quality of the image. And this is the given image. Okay, so it is a 4x4 image. So we will start with the solution. So the very first thing you have to see is how many bit resolution this image has. Now here it is already given that the image is 3-bit. So 3-bit means 2 raised to 3, that is 8 values it will have. That means the pixel values will range from 0 to 7. We already know the formula of histogram equalization, which we have studied previously. And the general transformation equation is S of k is equal to T R of k, where R of k is the values of the pixels before transformation and S of k are the values of the pixels after transformation. And here the transformation we are going to do is nothing but histogram equalization. So the formula comes to summation j is equal to 0 to k nj by n, which is almost equal to L minus 1 summation j is equal to 0 to k nj by n. So actually this is going to be the formula which we are going to implement here step by step. So the very first step is to plot the grayscale values R of k. So our grayscale values are nothing but 0 to 7. The next one is how many times per all these pixels repeat, which is n of k. So see, 0 pixel, is 0 pixel present here? No. So 0 is repeating 0 number of times. 1 is also not present here. So 1 is also 0 number of times. So on up to 4, there is no 4 in this image. But if you go to see pixel number 5, that is repeating 1, 2, 3, 4, 5 and 6 times. So pixel number 5 is repeating 6 times. Similarly, pixel number 6 is repeating 7 times and pixel number 7 is repeating 3 times. So 1, 2, 3 like that. The next step is we have to take the running sum or the CDF. So CDF means just this pixel will remain as it is. You have to take cumulative sum. Okay, so this plus this will be this plus this will be this plus this will be this. So up to this the values will be 0 only. 6 will be 6 plus 0 is going to be 6 only, whereas 6 plus 7 is going to be now 13, that is CDF, cumulative sum, and 13 plus 3 is going to be 16. Okay, so we have done what all steps till now? We have done this summation step in this part and nj by n step, that is we have done nj. nj is nothing but this one and summation is nothing but this step. Now we will do nj by n. Okay, so now what is n? N is nothing but divided by the total number of pixels. So how many are the total number of pixels here? This is a 4x4 matrix. That means the total number of pixels here are 16. So let us do nj by n. So 0 by 16, 0 by 16 and so on. Here it will be 6 by 16, 13 by 16 and 16 by 16, which is 1. And these all values will be zeros. The next thing is, so we have finished summation, we have finished nj, we have finished divided by n. Now next step is multiply by L minus 1. So what is L? L is the maximum pixel value, that is 8 here. So L minus 1 comes to be 7. Okay, so we will multiply by 7. So 0 by 16 into 7, which is always 0. So all these values will be 0. For this particular pixel, 6 by 16 into 7, 13 by 16 into 7 and 16 by 16 into 7. So we have completed the total formula. Now the last step is rounding off to the nearest integer. We always know that the pixel values for an image have to be in integers. So these all values will remain as 0 only. Now 2.62 will round off to 3. 5.6 will round off to 6. And 1 into 7 will be 7 as it is. Fine. So these are the new pixel values. So what has happened now? If you see the mapping, 0 will remain as 0 only, 1 will remain as 0, 2 will become 0 and so on. So here ultimately 5 will map to 3, 6 will map to 6 and 7 will map to 7. That means in this, if you we go to write the new image, that is after histogram equalization. If I try to write this image, for every 5 I have to replace it with 3 and 6 is replaced with 6 itself. So the new image will be 3, 6, 3, 6. 6 will remain as 6 only. 7 has mapped to 7 only here in this particular numerical. 5 is 3, 7 and again 3, 3, 3, 3, 7. So this is our new image after histogram equalization. Fine. So we have finished the first part, that is perform histogram equalization. Now draw the histogram before and after equalization. So instead of drawing the histogram, what I have plotted here is R of k, that is this gray level values against the number of times the gray level is repeating, that is n of k. Fine. So 0 to 7. Now I am having 5 is repeating 6 times, 6 is repeating 7 times and 7 is repeating 3 times. So this is 5 is 6, 6 is 7 and 7 is 3. So this is my histogram before histogram equalization. Similarly, I have drawn the histogram after histogram equalization. Okay. So here what is happening for this image? 1, 2, 3, 4, 5, 6 times our 3 is repeating. So 3 is 6 times, 6 is 7 times and 7 is 3 times. Okay, so this is my histogram after histogram equalization. So this part also I have completed. Now lastly we have to comment on the quality of the image. Now if you just see this histogram, we see that the pixels are lying, the concentration of the pixels is on the RHS. That means it is a bright image, right? And after performing histogram equalization, the pixels values have spread over the total range. That means it is converted to a high contrast image. So our comment is going to be, the original image was a very bright image and after performing histogram equalization, it has become a high contrast image as seen from the histogram. Thank you.